Hello guys, welcome to your Python programming tutorial short videos, and in this video we are going to be looking at introduction to Python numbers. First, some literature. The number data type, this is our 12th video, so if you haven't watched our earlier videos, you can go back and watch some of them. Now, the number data type stores numeric data. Number objects are created when you assign a value to them. Now, when you assign a value to number objects are created when you assign a number or a value to a number variable. Now I'm going to show you what that means. Now, for example, we have a value 10, we assign it to the variable var1 or the identifier var1. In that case, Python is going to create a number object in memory with the value 10. Here, this is an integer and this is going to be a float. We have looked at that in previous videos. Now, you can print here is a simple number. As you can see, a floating point number is a number with a decimal point, while an integer number is a number without a decimal point. So here we have print. We can print those two numbers as we have done here. You see 10 and 20. 2250.49. Forgive me, I'm trying to be fast here. All right. Now, you can delete an identifier once you create it. Now, when you say delete, for example, var2, we are trying to delete this identifier var2. Now, deleting this identifier var2 breaks the link between the identifier and the object in memory. The object in memory is going to remain there. Sometimes it's going to be garbage collected, like we have learned in the previous video, but the identifier is no longer going to exist. So the identifier is going to be taken away. And if you try to use the identifier, you're going to get something like this. Name var2 is not defined. No, Python considers it's not even defined. So another way of declaring variables, like we talked about in the previous video, is you can do it all on one line. In this case, num3 is going to be 400, num2 is going to be num3, which will be 400, and num1 will be num2 now, which is 400. So if you print this all, you're going to get 400, 400, 400. Now, if we delete all these numbers, you can use the delete operator to delete multiple identifiers by using the comma operator, the comma sign. Now, using the comma, you see you can delete num1, num2, num3. Now, if we try to print, let's say num2, for example, you're going to see Python will tell us num2 is not defined. Now, these are examples of integers. Like I told you, for numbers, we have integers, float, complex. We have integer, float, complex. So for example, these are integers. We can have positive and negative numbers. Remember, these are positive numbers by default. Numbers without a sign are positive numbers. And we have negative numbers where we place a negative in front of the number. Now, we also have hexadecimal numbers. Now, FF, for example, is 15. For those who are used to hex, if you are not used to hexadecimal, octal, or binary numbers, you don't need to worry about this. But those who have dealt with these kinds of numbers know what I'm talking about. So for hexadecimal numbers, you need to precede it with an OX. Now, O here is number O and X here is lowercase x. You can use uppercase X, or you can even use, when you're dealing with hexadecimals for A, B, C, D, E, F, you can also use uppercase to demonstrate the hexadecimal numbers. Now, these numbers are going to be stored in memory as normal decimal numbers. As you see from printing them out here, you see in memory they're going to be stored as normal decimal numbers, but when storing them, you can write them as hexadecimal. Octal, in this case, we have 0O, lowercase o, and in this case, we have 0B, lowercase b. Now, this is an octal number, you know, numbers from 0 to 7, and this is a binary number, numbers from 0 to 1. For those who are not aware, you don't need to worry about that. Now, if you print this all, you're going to see the binary number here of L here is 37. This is 1483. This octal number, this is it here. And this hexadecimal, we have 255. As you can see, we are printing them out. Pythons print them out as normal decimal numbers, not in their hexadecimal or binary form. Now, if we have some decimal numbers and want to convert them to hex, want to print them out in the form of hex, we need to use the inbuilt hex character. Now, this is a decimal number 1637, like we saw above. Now, if you print it out using the hex operator, you can see it converts. Python is going to convert it to an hexadecimal format and display it follow using the OX, like we did. Now, these are OX, OX, OX. As you can see now, if you want to print out in octadecimal, octaedral, sorry, you can use oct, and for binary, you can use bin, and you see it has an OB, just like we did when we were up. So you can make Python to print out decimal numbers in different formats. Now let's look at floating numbers. As you can see, floating numbers, we have 15 point, we can have 0.3, which should be automatically 0.3. We can have different form. You can also write them in standard notation. For example, 45.5 E5. It means e to the times 10 to the positive 5. Now, if you just write E5, it's still positive 5. But if you have a negative here, it will be 34.543 e to the negative 12. That's times 10 to the negative 12. In this case, we have 20.054 times 10 to the negative 10. If we print them all here, you see Python is converting them to the normal decimal form. You see this 45 here times 10 to the 45.5 times 10 to the 5. You see Python has written it here. Even in this case, Python has expanded it and written it in the normal decimal form or rational number form. So as you can see, here is some long digit which represent F11 here. So you see Python stores them normally as floating points, even though you wrote them like this. So Python stores them internally as floating points. Now we can also have complex numbers in Python. Now the real part, you just write it out. So this is 0 plus 4j, 3.24i plus 40j. You don't need to put the I for the real part, but you need to specify the j for the imaginary part. So you need to specify the j for the imaginary part. So you can see 3.24, 40j. So these are all complex numbers. You can see you can even use this exponential form when indicating the real or imaginary part. It still works normally. So as you can see, we have printed them out. Python prints them as complex numbers. Python writes them as normal decimal form for those which we specified in standard notation. Now, these are expressing floats in standard notation form. Now we had 5.2e to the 6 is the same as 5.2 times 10 to the 6. 2.36e to the negative 30 is the same as 2.36 times 10 to the negative 30. All right, that was a short video where I've shown you the different types of forms of Python numbers. We have decimal, we have integers, floats, and we have complex. Hope you learned something from this video, and see you in the next video. Have a nice time.